Okay, here we have a trig equation, sine x equals tangent x. Now my first temptation to do here is to change tangent to sine over cosine. So I'm just going to try it and let's see what happens. So that leaves me with sine x on the left and sine x over cosine x on the right. This may not work. It may work. It's just something that I see. I don't like using tangent very much because it's not standard. It takes a little bit more thinking to solve for, and sines and cosines are just a lot easier. Now I'm going to get rid of this denominator here by multiplying both sides by cosine x. So if I multiply the left by cosine x, I get sine x cosine x. And if I multiply the right by cosine x, that means that the cosine x on the top will cancel with the cosine x on the bottom, and I'll end up with just sine x. Now what I see here, two trig functions multiplied together equals one trig function. So I'm going to do that idea of bringing everything to one side and setting it equal to 0. Because now I see that between the two terms, I can factor out a sine x, which then separates the sine and the cosine into two different equations. If the product of sine x and cosine x minus 1 is equal to 0, that means sine x could possibly be 0, and cosine x minus 1 could possibly be 0. So if I think about my unit circle again, I'm looking for x values on the interval from 0 to 2 pi. Not all of them, just from 0 to 2 pi. And sine is 0 at 0 and pi. And then over here, I'm going to solve for cosine x. So cosine x equals 1 just at this one point here, which is x equals 0 and 2 pi. Well, technically over here, this is 2 pi as well, because again, we're including both endpoints. So the total number of angles, it looks like these are the same angles pretty much. So the three angles that solve this are 0, pi, and 2 pi.